Here I have 13 divided by 5, which is a division expression. I can also express this as 13 over 5, and that, as you know, is an improper fraction. Now the other way that I can express 13 over 5 is by a mixed number. Where the 13/5 could be broken up into its whole parts and fractional parts. How many fifths equal a whole? Right, 5/5. Am I to 13/5 yet? Not quite. Still breaking it apart. 5/5 more. That would be at 10/5. And then finally, I would break it apart again for 3/5. I know 5/5 is a whole, like I was saying, so that's 1 plus 1 plus 3/5. And our mixed number then is 2 and 3/5. We do have another way to think of this division expression, 13 divided by 5. Let's look at a standard algorithm. We do have another way of looking at that division expression, that standard algorithm. We will set up the problem. Here's 13, and our divisor is 5. The 110 cannot be divided into 5 parts. However, if we regroup it so that we have 13 ones that can be divided, goes in 2 whole times. 2 times 5 is 10. 13 minus 10 is 3. Now, if I could divide that 3, I would divide it into 5 parts. So that 13 divided by 5 is equal to 2 and 3/5. For my check, I have to see whether or not 2 and 3/5 times 5 equals 13 or not. And remember, that's the inverse operation. So I am looking at 5 times 2 and 3/5. Now 5 times 2 and 3/5 can also be expressed as repeated addition. And I have to add 2 and 3/5 together 5 times. If I regroup all of those whole numbers, that's 2 plus 2, 4, plus another 2 is 6, plus another 2 is 8, plus another 2 is 10, plus all of the 3/5. 3, 6, 9, 12, 15/5. So that's 10 plus 15/5. 15/5 is also equal to 5/5 plus 5/5 plus 5/5, and I know that 5/5 is equal to a whole. So that's 10 plus 1, 1, and 1, which is 13. And then so my check is accurate. There's one other way we can look at this 13 divided by 5, that division expression. We can look at it in unit form as fifths, because we're dividing by 5. So how many fifths am I dividing by 5? And this is the expression, this is the equation that we would end up solving. Something fifths divided by 5 equaling a certain amount of fifths. And then so we need to figure out this 13 here, how many fifths that 13 is worth, because I am still dividing by 5 here. Let's draw out a picture representation of a whole this time. So 1 whole is equal to how many fifths? Here's a whole. 1 whole is equal already to 5 fifths. If 1 whole is equal to 5 fifths, 2 wholes is equal to, right, 10 fifths. 3 wholes would be equal to 15 fifths. So, what would I have to do? How many of these would I need to equal 13 wholes? Right, 13 of them. So I would go 13, what, 5? I need 13 times 5 fifths. And that is equal to 65. So 65 fifths is equal to 13 wholes. 65 fifths divided by 5 is equal to 13 fifths. Just like my improper fraction that I was expressing before. 13 fifths. 13 divided by 5. Let's look at another problem. Let's look at the division expression 9 divided by 2. For unit forms, this divided by 2 means that we are going to look at halves. We're still going to divide by 2, and we're looking at halves. So we have divided by 2 equaling halves still, and we're thinking this 9 and this 9 divided by 2, we're expressing it right here. Exact same problem still. 9 is equal to how many halves? How many halves make up 9? Well, I know that 2 halves make up a whole, and we're talking about 9 wholes, so that's 9 times 2, which is 18. So, the division expression 9 divided by 2 can be expressed in unit form as 18 halves divided by 2. 18 divided by 2 is 9. So for that unit form, I've written 18 halves divided by 2 equals 9 halves. For the improper fraction, we keep that same order, and that's 9 divided by 2. So we have 9 divided by 2. Towards a mixed number, let's break it apart by its wholes. Remember that 2 halves equals a whole. So 9 halves is 2 halves plus another 2 halves plus another 2 halves. Oops, I'm only up to 6 halves so far. Plus another 2 halves plus 1 half. That's 1 whole, 2 wholes, 3 wholes, 4 wholes, 4 and 1 half. So our mixed number is equal to 4 wholes and 1 half. Now the other way that we can look at this is the standard logarithm approach, where we are taking 9 and dividing it by 2. 2 goes into 9 4 whole times with a remainder of 1. If we were going to divide that 1, we would have divided it by 2. And so that's why 9 divided by 2 is equal to 4 and 1 half. For our check, and actually let me make sure to show my work here. For our check, we start with our divisor, and we multiply it by our answer there. So we're going 2 times 4.5. We can express that as addition, where we're adding 4.5 together twice, in this case. Grouping our whole numbers, that's 4 plus 4 is 8. And a half plus a half is 2 halves, or 1. And then so that's 8 plus 1, which does equal 9. So that's how it is that we can look at division expressions in different ways, in unit form, as improper fractions, as mixed numbers, and how we can look at that standard algorithm approach to further our understanding.